6 notes. We just figured out that slip sort activity where you had to kind of sort out all those different slips of paper to produce solutions to the radical equations. The purpose now is just to get a little bit more practice. But before we go into this, you were asked to kind of compare all 4 boxes, and there's 3 similarities that sort of come out of all of those boxes. So I was just wondering if some of you could kind of speak to that a little bit for me. Like, what similarities did you see regardless of the color of paper or type of equation? Kristen. Perfect, perfect. Now, it can be in your own words. I know that this is for a notebook quiz, but that summary statement can be in your own words. You know, I say it basically the same way Kristen did. I say, you know, if an equation, when you look at it, has a radical of index n, you want to get rid of a radical of index n, you just raise both sides to the nth power. That allows you to get rid of that radical. Do you see something else, Alec? Yeah, you did. On all 4 of these, at the very end, you use SADMAP to solve a linear equation. But here in Honors Algebra 2, I'll be honest with you, as you go through the problems, they're not always linear at the end, but easing into the problems, all 4 of those, yes, use SADMAP to solve at the very end. That's true. Okay, there was one more. It occurred in actually 3 of the 4 boxes. Megan. Yeah, you got to get rid of anything that's with the radical if you can. Sometimes we can't always isolate the radical, but we try really hard to do that first. Excellent. You guys did it. Nice job. So essentially what you just summarized, and this will be our warm-up for tomorrow because this is a 2-day lesson, you just taught yourself the 3 steps to solving a radical equation. So let's make those steps official. The first thing you're going to do is the thing that Megan just said. You're going to go ahead and try to isolate that radical. And it says, if necessary, and to be honest with you, if possible, sometimes there's more than one radical in the problem, and it's impossible to isolate. So step 1 is if necessary and if possible. Step 2, this is what Kristen was talking about. You need to get that radical to go away in the problem. And to do that, you look at the index, and then you raise both sides to the same power as that index. That gets rid of the radical altogether. And then in the last step, and this was what Alec noticed, in all 4 of the problems that you folks just did, bless you, you had to SADMAP at the very end. So yeah, you have to solve. But here in Honors Algebra 2, it is not always a linear equation at the very end. Sometimes you have to solve a polynomial or a quadratic equation, which involves factoring, quadratic formula, maybe even graphing to find the zeros on your calculator. So you want to kind of keep your options open as far as, you know, what type of equation you could end up solving. There's one last step. We didn't make you do it in the slip sort activity because they were solved and checked and all good. The last step, step 4, for you folks is going to be to check for extraneous solutions. And hey, congratulations. As far as extraneous solutions go, you're actually 2/3 of the way there. This is the 2nd time in this class we've had to define that term. True story. We defined it a total of 3 times. So you will write down this definition one more time before this class is done in Chapter 8. Okay, so with that, we're coming up on a midterm soon. Does anybody remember the first case where we had to think about extraneous solutions? Do you, Alec? Same as your initials.
Yeah.
Ooh. I changed his mind.
I thought we did it when we were solving for I, like when we had to do.
Okay, that's an imaginary solution. That's different than extraneous. And extraneous, root word there's like extra. It's an extra solution that does not work when you plug it in. A couple of things happen in the algebra that force out this extra answer that it'll produce an untrue statement when you go to plug it back in. Yeah, very good. Your initials. Alec Voles, absolute value. Yeah. So, like, oh yeah, that's very coincidental. I thought he had totally had it. But yes, it's with an absolute value equation. Remember, you set the left side equal to the positive version of the right side, and then left side equal to the negative version of the right side, or the opposite of the right side. Sometimes we get some messed up answers there. that don't work when you plug them back into the original equation. So those will be the two cases that are on your midterm. The third one, obviously, we won't get to before the midterm. Okay, so these are our steps. Let's do them. In example 1, we're just going to do a couple of these today to make sure that your initial understanding is nice and firm. We have the square root of x plus 5 equals 12. So step 1, I isolate the radical. If necessary, it's already done. Yes, very good. Step 2, we eliminate the radical. So we isolate and then we eliminate. If I want to get rid of a square root, I must square both sides. So I have x plus 5 now equals 144. And then I solve using SADMAP. So in this case, I'm going to subtract 5 from both sides. I get a value for x of 139. I'm not done yet. I have to check. So here's me checking. When you check it, you must plug your 139 back into the original equation. So I'm asking myself right now, is 139 plus 5 the same as, underneath the square root, I should say, is that the same as 12? I'm trying to produce a true statement. Well, I know that 139 and 5 has a sum of 144. And this symbol here is the principal square root of 12. So that's the principal square root of 12. Ah, I said it wrong. The principal square root of 144. So I don't need to consider the plus minus case when I'm checking. The principal square root of 144 is 12. So I gave away my answer there. So that works. I generated a true statement when I was all done. Questions about that? Okay, let's do it again. This time around, my index is 3, which means I have to actually cube both sides to get that radical to go away. The radical went away. I don't know why I wrote it again. So we have 6 plus x equals 1,728. I subtract 6 from both sides, 1,722. Now I'm going to check it. I check it by substituting 1,722 back into the original equation. The idea here is that I should generate a true statement. So here's me subbing in 1722. Order of operations says I should take care of what's underneath that radical first. It's like a grouping symbol. And then cube root of 1728 is 12. I generated a true statement, so I know my answer is correct. Questions about 1 or 2? So now we make it a little bit harder. Let's go down to 3 here. So for number 3, I see that I would try to isolate the radical first. And if you'll notice, here's my radical expression, and it is not isolated. It is not by itself. I've been saying today, it has a little creeper right next to it. There's minus x sitting there. That minus x can't be there. I have to isolate that radical. So I'm going to add x onto both sides. So I have 2x plus 7 is my radicand, and then that's equal to x plus 2. If I want to get rid of that radical, I now have to square both sides. This is where I see the mistake. Oh, I heard it. What do? You have to FOIL, yeah. Good job. So we have x plus 2 times x plus 2 on that right side, and Kristen said it, you do have to FOIL. So you see that we don't get that linear equation like we did in the warm-up activity today. Little bit annoying. But I know that most of you are very, very good at solving this style of equation. What do you have to do first? Can't solve a quadratic with SADMAP. What do we do? A quadratic written like this, I should say. You have help. Go ahead, Gio. Yeah, you said it equal to 0. Is that what you were going to say? Very good. So I would subtract 2x from both sides and subtract 7 from both sides. So I get x squared plus 2x minus 3 actually equals 0. Ooh, and then we factor and solve. We finish this up tomorrow. You like factoring? That's good. 2 assignments for tonight. I want you to do the independent practice. There's 6 of them, and you know enough to do those 6. I would also start on your assignment bookwork for tomorrow night.